So right now I'm going to talk about partial fraction decomposition. And as dumb as it may sound, this is actually like a super important part of math. So if you're like even thinking about taking high level calculus and stuff like that, you're going to need to know how to do partial fraction decomposition. It comes up in linear algebra, all kinds of stuff. So it's a really, 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 really good thing to know how to do. And what it does is it takes an expression like this, okay, so a polynomial expression or whatever divided by another, right? And it splits this into, so we can say it equals some constant, we'll call it a, over a linear factor. So I'll just call it, I don't know, I'll just call it x plus, what's a good number? X plus little a, I'll call it. And then plus b over x plus little b. Okay, where a and b and then uppercase a and b are also constants. Okay, and x is a linear variable, right? So x plus a, that's a linear factor or linear term because its highest degree is 1. Same with x plus b. And partial fraction decomposition only works if the denominator's degree is higher than the numerator's. In this case it is, right? Because the degree of a is 0 because it's a constant, the degree of x plus a is 1. So the way we can do this is, the first thing I'd do is I'd factor the denominator of the original question. So what we have right here is we have 5x plus 3. We can't factor that, right? It's just kind of stuck the way it is. But I'll actually try and keep this as neat as possible. X squared plus 6x minus 7, we can factor that into, well, x plus 7 times x minus 1, right? And what we want to do now is we want to say that this equals, right, this new kind of way to write it, so 5x plus 3 over x plus 7 times x minus 1. We're going to say that that equals some constant a over one of these linear factors, let's do x plus 7 first, plus a constant b over the other linear factor x minus 1. So now we have an equation set up. Okay, and what we want to do is we want to multiply both sides by x plus 7 times x minus 1. And if we do, we're just going to get the left side, 5x plus 3, is going to equal, well, the x plus 7s are going to cancel for the first term on the right. So it's going to be a times x minus 1. And then if we do that to the other one, right, we're going to get x plus 7 times x minus 1 times b, and then that's being divided by x minus 1. So the x minus 1s are going to cancel, and we're going to get plus b times x plus 7. So you might think that we need a system of equations to solve this, and we actually don't, because a and b, they're both multiplying into something. So for example, if we said let x equal 1, well, when x is 1, right, and we plug in 1 for x, this will be a times 1 minus 1. So if x was 1, this would be 5 times 1 plus 3. This would be equal to a times 1 minus 1 plus b times 1 plus 7. So we still don't know what a or b are, but this is a times 0, so we can forget about this for now. And on the left we have 8 equals, well, b times 1 plus 7, which is 8b. Divide both sides by 8, and we just get b is equal to 1. Well, that's great. We didn't even need a system of equations. We were just tricky by putting in x equals 1 into this equation. And we can do the exact same thing with x is negative 7, because when x is negative 7, the b term will now disappear. So we'll say let x equal negative 7. Right, so when x is negative 7, this will be 5 times negative 7 plus 3. That's going to be equal to a times negative 7 minus 1. So notice how this doesn't disappear anymore, right, because that's going to be negative 8a. But then we'll have plus b times negative 7 plus 7. Negative 7 plus 7 is 0, so this term is gone. And we have now 5 times negative 7 is negative 35 plus 3. So negative 32 equals, like I said, this will be negative 8a. Solve for a, we divide both sides by negative 8 this time. We get 4 is equal to a. Okay, well, what does a and b even mean? Because the original expression didn't even have a and b in it, it just had x. Well, remember, a and b represented the constants that we had in our numerators of our split up fraction. So if a was 4, this will be 4 over, and then it was over x plus 7. And then remember, b was positive 1, so plus 1 over x minus, I think it was 1. Yes. So this is an equivalent way to write what we started with. 5x plus 3, 5x plus 3 over x squared, and then it was plus 6x minus 7. And you'll find that if you kind of simplify this, get these into common denominators, combine them together, it's going to be the same thing as this right side here. And you might be thinking, well, like, what's the point of even doing this? Because we started with a single fraction, a single rational expression, and we split it up into 2. What's the point of even doing that? Well, sometimes there's not, to be honest. Sometimes it's just kind of stupid. It's redundant. There's not a whole lot of point to it. But in calculus, when you're doing something like integrals or derivatives, right, taking the integral of this is essentially impossible without doing some manipulation. But now if we take the integral of the left side, we can split this into 2 different integrals. So we can say this is the integral, right, of 4 over x plus 7. And we can go plus the integral of 1 over x minus 1. And I can solve this in the next video. I don't want to kind of go too far here, but if you're not a calculus student, this is still super important. So in my next video, I'll talk about how we can finish this question off using calculus to integrate it. But for right now, that's just a super useful way to take a rational expression like this or a fraction and kind of blow it up into 2 fractions that are adding or subtracting together. Okay, thanks for listening, and I'll see you later.